video for page 340, and I know there was two pages, 340, and I believe it was 347. I'm going to actually split them up and put them on two separate videos. And all these videos I send out, just more, it'll show me working out the problems, but make sure that the main thing is that if you have questions on any of them, hopefully you can skip to it and get to those questions and answer any questions that you have. First, on number 4, it talks about indirect proofs. We didn't talk about indirect proofs in class because that was the day that we had the shortened time. So I wanted to make sure that we got through everything else, so we didn't really talk about indirect proofs. But the first few here sort of deal with indirect proofs. And all an indirect proof is exactly what the name sounds like. It's proving something, but like going a roundabout way to get to it. So instead of maybe proving that something is true, we're actually proving that something else isn't true to show us that what we want has to be true. So that's all an indirect proof is. On number 4, you can just skip it because we didn't go over it. Number 7, and again, I'm going to be moving extremely quickly on these. Number 7, determine which two statements contradict each other. So if we're looking at that, A says triangle LMN is a right triangle. B says angle L and angle N are congruent. And C says triangle LMN is equilateral. Well, A and C contradict each other because you cannot, that's supposed to be a C, you cannot have a right triangle that's also equilateral. Remember, we had a rule a while back, a theorem that said if a triangle is equilateral, then it's also got to be equiangular. Well, if a right triangle was equilateral, then that means it's also equiangular. That means all the angles would have to be 90 degrees, and it's not possible for a triangle to have all angles 90 degrees, or 3 angles that are 90 degrees. So that one's A and C. Number 8, both X and Y have a measure greater than 20. Both angle X and angle Y have a measure greater than 20. B says both angle X and angle Y have a measure less than 30. And C says the measure of angle X plus the measure of angle Y equals 62 degrees. Well, in this one, it's B and C that contradict, because if both angles are less than 30, both less than 30, then can't add to 62. If both of them's less than 30, at least one of them would have to be larger than 30 for them to add up to 62 degrees. So B and C contradict each other. Number 9. On number 9 and 10, just sketch something close. It doesn't have to be perfect. We want an acute scalene triangle. With an acute, I know it says use a ruler and all that stuff, I don't care about that. We want an acute scalene triangle. That means we want a triangle that's got 3 acute angles and all the sides are different lengths. So just do the best you can. It doesn't have to be perfect. Something maybe like that. And you could, even if you wanted, you could stick in some numbers here or something to tell how much each angle is and how much the sides are or something. But I'm not too concerned about it since we're not here at school. And then a right scaling. Well, a right scaling, the only thing that really matters here is it's got one right angle in it, and then we know all 3 sides, since it's scaling, have to be different lengths. Number 11. Number 11, says, and my triangles might not look exactly like their triangle, but it's gonna be close. It says, list all the angles from smallest to largest. So we're just gonna make a list of them. And this one, remember our rule said that the shortest side has to be across from the smallest angle. So 6 is the shortest side, well then that means that one over there has to be the smallest. The 9's the next smallest, so that angle is going to be the one that's in the middle. And then the 10 is the longest side, and it's across from angle T, so that's going to be the largest angle. And when we go to list them in order, from smallest to largest, you can just list angle S. You can use the alligator mouse if you want, but it's probably easier to list, or just use the commas. So angle S is the smallest, angle R is the next smallest, and then angle T is the largest. That would be your answer for number 11. Number 12 is the same kind of problem. They give us a triangle that looks like this. This side's 28, this side's 25, and this side's 13. This is K, L, and J. They want us to list the angles from smallest to largest. Well, the smallest side is 13, so the smallest angle has to be angle J. The next smallest side is 25, so the smallest, or the next smallest angle has to be angle K.
I still have one document.
And then the largest side is 28, and it's across from angle L, so that has to be the largest angle. That would be your answer on number 12. Number 13. 13 does the same thing. It's just 8. It's just using the angles instead of the sides. So number 13. I'm probably gonna skip a couple of these because you can figure them out. I'll do 13, then I'll probably do like 16 or something. So 13. They tell us that this angle is 67 degrees, this angle is 62 degrees, 7, and this angle is 51 degrees, and this is A, B, and C. We want to list the sides from shortest to longest, so we want the sides this time from shortest to longest. Well, the shortest side's got to be across from the smallest angle, so that has to be that side. So segment AB has to be the shortest. Make sure you're using your symbols. 62 is the next smallest angle, so that has to, the side across from it has to be the next shortest side, so BC has to go next. And then 67 is the biggest angle, so it has to be across from the longest side, and that would be segment AC. Make sure you're using your symbols. Again, I'm going to skip. 14 is basically the same thing. 15, so 14 you can do on your own there. 15, same idea. The only difference on 15 is you have to find the missing angle. So you'd have to add 127 and 29, subtract that answer from 180. That would give you the missing angle. Then you can tell which side is the longest and shortest and all that. 16 sort of the same thing. I'm going to do it. 16, they give you a picture. It looks like this. That's a right angle. This angle is 33 degrees. This is F, D, and G. First thing I got to do is I'm going to take 90 plus 33. It's 123. Take 180 minus 130 or 123. Borrow here. That gives me 7, 5. So this other angle is 57 degrees. Once we know that, now we can list the sides from shortest to longest. This is the smallest angle, so side across from it, which is
DF or FD has to be the shortest. Then this is the next one, and side across from it is FG. And then the longest side has to be across from the right angle, and that is segment DG. So longest side always across from the biggest angle, and vice versa. Next one, problem number 17. 17, 18, 19, and 20 are basically the same thing. It says describe the possible lengths of the third side of the triangle. Easiest way to do this, we talked about this in class, you write third side and put your two alligator mouse using less than. On this side, we subtract the two sides that they give us. On this side, we add the two sides that they give us, and that'll tell us that that third side has to fall between those two numbers. It's the only possible way for it to make a triangle. So on this side over here, it's 12 minus 5, which is 7. And on the other side, it's 12 plus 5, which is 17. So we know if you don't like using the alligator mouse, I'm sure what just happened there, but if you don't like using the alligator mouse, you could write it out and say the third side must be between 7 and 17. It can't be 7, it can't be 17, it's got to be in between them, but that third side has to have a length between 7 and 17. Number 18, the two lengths they give us this time are 12 and 18, so 12 feet and 18 feet. Again, all we're going to do, I'm going to just write it this way, the third side, put the alligator mouse. On this side you subtract the 2, so that'd be 6. On this side you add the 2, so that's 30. So our third side's got to be between 6 feet and 30 feet. 19, got to be careful when they do stuff like this to you. They say 2 feet, and the second side that they give you is 40 inches. Well, you can't just do them because there's two different units there. So what we have to do to this 2 feet, very first thing, is change it into inches. And the way we change it into inches is multiply by 12, and you get 24. So now we use the 24 and we use the 40 to find it. So the third side has to fall between, on this side we subtract 40 and 24, and we get 16 inches. And on this side we add 24 and 40, and we get 64 inches. So that third side has to be between 16 inches and 64 inches. Number 20. It says you got two sides and it's 25 meters and 25 meters. So apparently we have an isosceles triangle, which two of the sides are the same. Well, the third side's got to fall between. This side we subtract the 2. 25 minus 25 is 0. So it can go all the way down. It can never reach 0, but all the way down to 0. And then the other side we add the 2, and that's going to be 50 meters. So between 0 and 50 meters, that third side. Uh, 21 through 24. On 21 through 24, they just want you to tell whether those three numbers can make up a triangle and explain your reasoning on these, what we do on these. Is you just pick any two sides, and you gotta check all three. So we want any two sides, gotta be
add up to be more than the third side. So 6 plus 7 should be greater than 11. And that's true, 6 plus 7 is 13. Then we do like 6 plus 11, and that should be greater than 7, and that works. And then we can do 7 plus 11, and that should be greater than 6, and that works. So yes, those three can be a triangle. 22, they give us 3, 6, and 9. If you can figure out that one of them's not going to work, then do that one first, because then that's all the work you got to do. In this case, 3 plus 6 should be greater than 9, and it's not, so it's not greater. So no, this one cannot be a triangle. 3 plus 6 equals 9. It's not greater than. Problem 23, they give us 28, 17, and 46. And we just, again, pick two sides. 28 plus 17 should be greater than 46. Well, 28 plus 17 is 45. 45 is not greater than 46. So that means no, that one won't work to be a triangle. So you can't have a triangle that has sides 28, 17, and 46. 24 says 35, 120, and 125. So we just start picking sides. Any two sides should add up to be more than the third side. So I'm just going to do 35 plus 120. That should be greater than 125, and it is. Then I'm going to pick 35 plus 125, and that should be greater than 120, and it is. And then I'm going to pick 120 plus 125, and that should be larger than 35, and it is. So yes, this one can, those three numbers can form a triangle. Next, number 29. 29, they give us a picture. Looks like this. Again, my triangle might not look exactly like theirs. That's U, T, and V. This is 84 degrees. This is 48 degrees. And we can find the third side. 84 plus 48 is 12. 132, we subtract that from 180, you get 8, and to borrow there, that's 4, so 48. Make sure I did everything right there. So that angle's 48 degrees. Well, if that's 48, then that tells us the two sides across from the two 48-degree angles have to be the same. So it's an isosceles triangle. That says segment UV is greater than segment TU. So UV is greater than TU. Well, UV is across from the 84 and TU is across from the 48. So A is true, so A checks out. B, UV plus TV is greater than TU. UV plus TV has to be greater than this third side. Well, that has to work for every triangle. Any two sides got to add up to be more than the third side, so that one checks. Next one says UV is less than TV. UV is less than TV. Well, UV is across from the 84-degree angle, which should be the biggest side, so it can't be less than. So this is probably going to be our answer. Let's check out D just to be sure. TUV is an isosceles triangle. We said that at the beginning. These two sides have to be congruent,
So it is isosceles, so that one checks. So our answer for this one is C. C is the one that doesn't work. Number 30. On number 30, it says, in triangle RST, which is a possible side length for ST, select all that apply. So we got this triangle, this side's 65 degrees, or I'm sorry, this angle's 65 degrees. This is 56 degrees. We can find the other one by adding those two, 65 plus 56. That's 11, carry that, that's 121, subtract that from 180. That's 9, bar over there, that's 59 degrees, so this one's 59 degrees. Just looking at this, we can sort of figure out which sides have to be the longest and shortest and so on and so on. They tell us that that side over there is 8. Well, we know that this is the smallest angle, so that has to be the shortest side. So 8 has to be the shortest. So when we look at A, B, and C, A is 7. Well, we're looking for ST. I should have labeled this. That's S, T, and R. So we're looking for this side right here. Well, it can't be 7 because it can't be shorter than 8. B says 8. If this is 56 and this angle here is 59, for this side over here to be 8, those two angles would also have to be the same, and they're not, so it can't be 8 either. C, 9. It's across from a bigger angle than the 8, so 9 could work. And then D says 10. Well, we're not sure exactly how much it is, but we know it has to be bigger than 8, has to be bigger than this side. So 9 and 10 are the two answers. It said select all answers that apply, or all answers that work. $35. They give us this picture, and it says you can estimate the width of the river from point A to the tree, and the tree's over here at point B, so the tree's right up here. By measuring the angle to the tree at several locations along the riverbank. The diagram shows the results for locations C and D. So they gave us all this. If we're looking at this, and we got all the measurements that they gave us here, that's 50 degrees, this is 40 degrees. They tell us that's a right angle, well then this also over here has got to be 90. And if that's 90, this is 40, we can find this angle up here, which is going to end up being 50 degrees, because 3 angles of a triangle must add up to 180. And if this is 50 and this is 90, then this up here has to be 40 degrees. And we can look at this and we can decide that in this picture, these two sides in each triangle have to be the longest. That's the longest in that triangle on the left, and that's the longest in the triangle on the right. And when we look at this side, that's what we're actually trying to figure out. We know that in the triangle on the left, that has to be the shortest side. It has to be shorter than the other ones. So from that, if this side has to be shorter than the other two sides in that triangle, then we know that that distance across the river, the distance must be less than 50 meters. And if if that distance, so that's what we get from this triangle on the left. Then if we look at the other side, or the other triangle, we know that this one down here has to be the shortest side, and that one over there had to be the longest side. Well, this has to be the side that's in the middle of them. So what we can get from that is the fact that if it's in the middle between this side and this side, well, it has to be longer than 35. So that distance has to be more than 35 meters. Well, if it's more than 35 meters and less than 50 meters, so we got a good range there. We know, it's got to be between 35 and 50. It can't be anything else. That was part A. Part B, they said, what could you do if you wanted to get closer? Well, what you could do is you could make more measurements. So you could go and find more angles and more measurements and keep whittling it down till you get closer and closer. Uh, 36. They tell you this information. And part A says, write two inequalities to represent the possible distances from Granite Park to Fort Peck. So that's this distance right here that we're trying to write inequalities for. So this is part A. And all we're going to do to write these two inequalities is we know that to find, or we know that this third side of the triangle must be between two certain numbers. And the first number, the way we're going to get the first number is we're going to subtract the two. So 565 minus 489, that's going to give us the low end. Let's see, that is, if you grab your calculator and do it, it's going to end up being like 76. So we know that that distance x that they gave us has to be greater than 76. Then to find the other end, the highest it could go up to, we add the two. So 565 plus 489, and that's going to equal, if we come out here and do it, 565, 489, you could grab your calculator, you just add them up, so that's 14, 15, that's 9, 10, so 1,054. So the longest it could go up to is, or x has to be less than 1054 kilometers. These are kilometers. So we know that the distance has to be between 76 kilometers and 1,054 kilometers. Part B says, how is your answer to part A affected if you know that the measure of angle 2 is less than the measure of angle 1 and the measure of angle 2 is less than the measure of angle 3? So if it's less than 1 and it's less than 3, then that means angle 2 right here has to be the smallest angle in the triangle. If it's the smallest angle, then that means that x over here, that distance has to be the shortest side in the triangle. And if it's the shortest side in the triangle, then we know that it can't be anywhere near that. It can't go up to like 1053 or something because it's got to be the shortest. Well, if it's got to be the shortest, then the highest it can possibly be or go up to is 489. So now we know that that side has to be between 76 and the highest it could go up to, or it can't even go up to all the way up to it, but 489. So now we know instead of being between 76 and 1,054, we know we have to be between 76 and 489.
Alright, 37 is probably one of the harder ones on the page. On 37, you gotta really think things through and do a lot of thinking with this one. They tell you that these two angles are congruent. So we know that, just keep that in your mind. The other thing that we're gonna do is we're gonna look at the angles in here. We wanna list all the angles from smallest to largest. Well, if we're looking at this, if we just look at the triangle on the left, just this triangle, we just look at it, then we know that this angle up here has to be the smallest. So I'm gonna put just SM there for small. That has to be the smallest one in this triangle. This angle's across from the 41, so that has to be the middle one. And then the largest angle, I'm just gonna put LAR over here. That has to be the largest one in that triangle. If we go over to the triangle on the right, so this triangle over here, and we do the same thing, the 15.6 is the longest side, so this has to be the largest angle because it's across from it. Then the 15, this has to be the middle one because it's the next biggest angle, or the next biggest side, I mean. And then this one up here has to be the smallest because it's across from the 11.7. Now what you got to do is use your brain a little bit and say, okay, if this angle and this angle are congruent, then, and this is the largest angle in this triangle, and it's this one over here is the middle sized one in this triangle, then that means both these angles are as big as the biggest angle in this triangle, the triangle on the right, and that means this angle, if these two are as big as the largest one over here, these two, when you add them up to get all three of them to get 180, these two added together have to be more than this one and this one added together. So that means that this angle up here has to be the smallest one out of the whole picture. And when we go to name that they want us to list them from smallest to largest. So when we go to name that angle, that's angle WXY. That has to be the smallest one. Well, the middle one over here is the same as this one. But what's going to end up happening here is then this angle right here has to be the next smallest. So angle YXZ has to be the next smallest. So we've taken care of this angle, we've taken care of this angle. Now once we have that, we know that this middle angle and this one are the same size, so those two are the same size, and this is the largest one in here, so the next smallest one has to be that one right there, and we'll just call it angle Z. We only need one letter for it, angle Z. That's a terrible Z. Should say angle Z. So we've taken care of that one. Now we know this one over here is larger than both of these two, because they're the same. So we're going to list those two next. It doesn't really matter which order we list them in because they're the same size. So we'll list them angle WYX and angle XYZ. And then that leaves us with, and I'm running out of space over here, that leaves us with our very largest angle in the whole picture, which is angle W. A little tough. You just got to put some thought into it. Think it all the way through. Letter 40, or number 40, not letter 40. On number 40. Number 40, they want you to figure out any possible values of x. So we're just going to give a description. We can't actually figure out what x is because they don't tell us this is isosceles triangle or equilateral triangle or any of that stuff. So we don't know that all these sides are the same or any two of them are the same. But what we can do, we have our theorem that we talked about last time that says any two sides must add up to be more than the third side.
So the first thing I'm gonna add up, I'm gonna say x plus 11 plus 2x plus 10 has to be greater than the third side, which is 5x minus 9. And we'll solve that here in a second. I'm gonna come over here and go ahead and write the other two inequalities out. X plus 11 plus 5x minus 9 has to be greater than the other side, which is 2x plus 10. And then the third thing is 2x plus 10 plus 5x minus 9 has to be greater than x plus 11. Now what we got to do, and you solve inequalities, you should have learned in algebra, you solve inequalities just like you solve equations. And I'm going to do this very quickly. We solve these equations here, collect like terms, so we get 3x, 11 and 10 give me 21, is greater than 5x minus 9. Subtract 3x on both sides, you end up with 21 is greater than 2x minus 9. Add 9 on both sides, you end up with 2x on that side greater than there 30. Divide by 2, divide by 2. So you end up with just x on the right hand side and 15 on the other side. And if you turn this around, that's going to say x with the point going to it. So x has to be less than 15. When you turn it around, it's just like you're looking at it in the mirror. Just turn it completely around. Don't forget, everything flips, even the alligator mouth. We come over here, we do the next one. We get 6x combining like terms. 11 and negative 9 give us plus 2 is greater than 2x plus 10. Subtract 2x on both sides. Pen's not working very well. You end up with 4x plus 2 is greater than 10. Subtract 2 on both sides. You end up with 4x is greater than 8. Divide both sides by 4. These cancel out. You're left with x is greater than 2. So we know x has got to be more than 2. It's got to be less than 15 so far. We do the rest of it, or the last one here, and we collect like terms. We get 7x plus 1 is greater than x plus 11. Just collecting like terms. Subtract 1 on, or I'm sorry, it doesn't matter. Subtract 1 on both sides. We should have done the x's first. Doesn't make a whole lot of difference. And you end up with x plus 10 over here. Subtract x on both sides. You end up with 6x is greater than 10. Divide by 6. Divide by 6. 6 isn't going to go into 10 evenly. All right, so it's going to end up being x is greater than 6 will go into 10 one time. So 1 whole with 4 left over. So 1 4/6 or 1 2/3. Same thing as 1 2/3 if we reduce it. Well, we're saying x has to be greater than that. Well, we look up here and we already know x has to be larger than 2. So we're already greater than that. So this one here doesn't really help us any. So we know that x has to be, our x there must be between 2 and 15. We know it's got to fall between those two. Problem 42. On problem 42, just looking at it, what is the shortest route to get from your house to the library, well, they sort of tried to trick you on this one a little bit. Your house to the library, the shortest route is gonna be Washington Street. And our reason is just the shortest distance between any 2 points is a segment. All right, you probably, something that most people say is shortest distance between any 2 points is a straight line. Well, we know all lines are straight, so it's just, the shortest distance between your house and the library has to be, that segment, Washington Street, going directly there. Problem 50. Give us a picture, it looks like this. And this is A, this is E, this is B, this is C, this is D. They say name the included angle between the two pairs of sides. So they want the included angle between segment AE and segment BE. Remember, included angle just means the angle that falls between those two. Well, that's this angle right here. It's that angle. All right, we're going to name it with 3 letters. So angle AEB is the included angle. 51, same picture. So I'm not going to draw it again. Segment AC and segment DC. Segment AC, that's this whole thing. And segment DC is this bottom. They want the included angle. So it's going to be that angle right there. That's the angle we're looking at. So we just name it angle ACD. Remember to use your symbols, your angle symbol. And for these, we had to use 3 letters to name the angles. So that's all of page 340. I'm going to do 347 on a different video. Again, on all these, don't just watch the whole video. Try to use it to help you figure out if you're making mistakes anywhere or any problems that you're having trouble with.